Our entire planet, our solar system, and the Milky Way galaxy itself are screaming through the universe at a speed that is almost impossible to comprehend. We are not just drifting along with the expansion of space, we are being pulled with incredible force toward a single mysterious point in the cosmos, a point we now call the Great Attractor. For nearly half a century, this object has baffled astronomers, defied simple explanations, and forced us to rethink everything we know about gravity, cosmic structure, and the hidden makeup of the universe. Today, we are going to answer the question that has haunted astrophysics for decades. What exactly is the Great Attractor, and why is it dragging our galaxy across millions of light-years of space? Let us start with the basics. In the early 1900s, Edwin Hubble changed astronomy forever when he discovered that the universe is expanding. Galaxies are not stationary, they are moving away from one another as space itself stretches. This expansion follows a clear pattern known as Hubble's law, where the farther a galaxy is from us, the faster it appears to recede. For years, scientists thought this uniform expansion explained all large-scale cosmic motion. But by the 1970s and 1980s, careful observations began to reveal a shocking contradiction. The Milky Way, along with every nearby galaxy in our local group, was moving faster than Hubble's law predicted, and it was all moving in the exact same direction. Instead of floating apart evenly, we were all being tugged toward a patch of sky in the constellations Hydra and Centaurus. Our peculiar velocity, the speed at which we deviate from the general cosmic expansion, is roughly 600 kilometers every single second. To put that in perspective, that is more than 2 million kilometers per hour. Nothing in our known neighborhood could create a gravitational pull strong enough to cause that kind of motion. There had to be something massive, something invisible, and something completely unknown waiting for us in that distant region of space. In 1986, a team of 7 astronomers, later nicknamed the Seven Samurai, made history. They measured the velocities of nearly 400 elliptical galaxies and confirmed what many had suspected: an enormous, unseen gravitational concentration was pulling entire galaxy groups toward it. They named this mysterious source the Great Attractor. But here is the cruel twist of cosmic luck. The Great Attractor lies directly behind the zone of avoidance, a thick band of dust, gas, and stars that makes up the plane of the Milky Way. This zone blocks roughly 20% of the sky from visible light telescopes, meaning we could not see what was pulling us. We could feel its gravity, we could map its effect on galaxies, but we could not observe the source itself. It was like knowing a storm was coming, but being unable to look out the window to see it. For years, the Great Attractor remained a ghostly presence, an effect without a visible cause. Scientists knew the Great Attractor had to be extraordinarily massive. Early estimates suggested its total mass equaled 10 quadrillion times the mass of our Sun, or about 10,000 times the mass of the entire Milky Way. Such a concentration should be blazing with light, filled with bright galaxy clusters and cosmic fireworks. Instead, we saw almost nothing. This led to wild theories. Some thought it was a supermassive black hole, the size of an entire galaxy. Others wondered if it was a cosmic defect, a ripple in space-time. A few even suggested it was a sign of physics we had not yet discovered. But as technology improved, astronomers began to pierce the veil of the zone of avoidance using infrared radio and X-ray telescopes that can see through dust and gas. These tools do not care about the Milky Way's glare. They detect the heat and high-energy radiation that visible light cannot. Slowly, the fog began to lift, and the truth about the Great Attractor started to come into focus. What we found changed our map of the universe. The Great Attractor is not a single monster object, not a single black hole, not a single galaxy cluster. It is a vast, sprawling region of concentrated mass, the gravitational heart of a titanic structure called the Laniakea supercluster. Discovered in 2014 by a team led by astronomer Brent Tully, Laniakea means immeasurable heaven in Hawaiian, and the name could not be more fitting. This supercluster spans more than 500 million light-years and contains more than 100,000 galaxies, including our own Milky Way, the Virgo cluster, the Hydra, Centaurus supercluster, and countless others. Think of Laniakea as a cosmic river basin. Every galaxy inside it flows downhill toward the lowest point in the gravitational landscape. That lowest point, that central drain of the entire basin, is the Great Attractor. It is not a thing, it is a place, the focal point of gravity for our entire corner of the cosmos. At the center of the Great Attractor lies the Norma cluster, also known as Avel 3627. one of the densest galaxy clusters in our nearby universe. This cluster is packed with thousands of galaxies, all swirling together under immense gravity. But even the Norma cluster alone is not massive enough to explain the full pull we measure. The secret lies in something we cannot see at all: dark matter. Dark matter makes up about 85% of all matter in the universe, yet it does not emit, absorb, or reflect light. We only detect it through its gravity. The Great Attractor, overwhelming pull, comes from a combination of visible galaxy clusters, intergalactic gas, and a massive invisible halo of dark matter that binds the entire structure together. This dark matter web is the invisible skeleton of the universe, and the Great Attractor sits at one of the densest knots in that skeleton. Later studies revealed another layer to the mystery. Beyond the Great Attractor lies an even larger structure called the Shapley Attractor, an even more massive supercluster that tugs both the Great Attractor and our galaxy toward it. Together, these gravitational giants create a cosmic current that carries us across space. The discovery of the Great Attractor has rewritten our understanding of cosmic structure. For a long time, we pictured the universe as a random scattering of galaxies. Now we know it is organized into a vast, intricate web called the cosmic web. Filaments of galaxies and dark matter stretch across the universe, surrounding enormous empty regions called voids. The Great Attractor lies at the intersection of several of these massive filaments, forming what astronomers call the Norma Wall, a colossal chain of galaxies and galaxy clusters that stretches hundreds of millions of light-years. It is one of the largest structures we have ever identified, and it governs the motion of every galaxy within hundreds of millions of light-years. This is gravity on the grandest scale imaginable, shaping the destiny of entire galaxies and superclusters. You might be wondering, if we are being pulled toward the Great Attractor, will we eventually crash into it? The answer is no. The universe is not only being pulled by gravity, it is also being pushed apart by dark energy, the mysterious force driving cosmic expansion. Dark energy is winning the battle in our universe. Over time, the expansion of space will accelerate, and the pull of the Great Attractor will grow weaker relative to the stretching of space-time. We will continue to drift toward it, but we will never reach it. Instead, we will remain part of the great cosmic flow, moving gently along the curves of space-time, shaped by dark matter and galaxy clusters across billions of light-years. Studying the Great Attractor is about far more than satisfying curiosity. It is about understanding our place in the cosmos. We live on a small planet, orbiting an ordinary star inside a typical galaxy on the edge of a supercluster, being pulled by a gravitational beast we cannot fully see. This journey of discovery teaches us humility and wonder. It shows us that the universe is far more complex, more connected, and more magnificent than we ever imagined. Every time we solve one cosmic mystery, we uncover 10 more, pushing the boundaries of human knowledge farther into the dark. The Great Attractor is a reminder that the universe is full of hidden forces, invisible structures, and secrets waiting for us to find them. It is a testament to the power of astronomy, to the curiosity of human beings, and to the relentless drive to understand the world and the cosmos beyond our own small corner. For decades, the Great Attractor was one of the greatest unsolved mysteries in astrophysics. We could feel its pull, but we could not see its face. Thanks to decades of observations, cutting-edge telescopes, and the brilliance of astronomers around the world, we have turned that ghostly mystery into a concrete part of our cosmic map. We now know it is the heart of Laniakea, a knot in the cosmic web, a concentration of galaxies and dark matter that shapes the motion of everything around it. It is not a monster, not a threat, not a cosmic anomaly. It is a natural part of the universe, grand structure, a beautiful example of how gravity weaves galaxies into the largest patterns in existence. The next time you look up at the stars, remember, you are not standing still. You, along with every living thing on Earth, are riding a galaxy that is racing through space, pulled by an invisible giant, millions of light-years away. The Great Attractor is out there, silent and unseen, guiding our galaxy's journey through the immeasurable heaven we call Laniakea. And as we keep looking, keep exploring, and keep pushing our telescopes deeper into the dark, we will continue to uncover the secrets of this amazing force and the countless other wonders that fill our infinite universe. Please like, comment, share, and subscribe to the channel.